Okay, so first I start with my quadrantal values because I have those memorized. I also start with degrees first because those I already know them. And then I go to radians, and then I go to my points. So coming on the inside, this would be 0 degrees. And then I know that if I do, I hate to say halfway, but if I rotate, watch my arm, if I rotate to here, is anyone out? No, okay, good. So I can say, watch my arm. If I rotate here, I know this is 180. And then up here would be 90. And then 270. And then 360. Then I'm going to fill in the degrees for the 30, 45, and 60, and then count them around. So this is 30, 45, 60. To get the values in the other spots, you're using those reference angles. So if you need to, you could say, if this was 30, I'm going to hit that same mark, but in the other quadrants. So that would be this one, and this one. It should look symmetrical, right? Red means wrong here. Like if you get over here and you're doing that, something's off. Okay, it should be symmetrical. So over here, I am 30 degrees before 180, which means it's 150. Here, I'm 30 degrees after 180. And here, I'm 30 degrees before 360. Now I'm going to repeat with 45. 45 is the easiest one. It's the one in the middle. So if here I'm 45 degrees before 180, so that would be what, 135? My arithmetic is terrible sometimes, so make sure to help me out. 180, now I'm 45 after 180, so what, 225? Now I'm 45 before 360, so 315. Is that right? 60 minus 45.
Yeah.
Is it 315?
Is it 315?
I don't know. Don't make me feel stupid because I should know arithmetic, but I struggle in my head.
Let me observe.
I can do the challenging stuff. I struggle with basic numbers sometimes. They're hard.
Is it Pierce?
Now I'm going to hit the 60 mark. So this is 60 before 180. This is 60 after 180. This is 60 before 360. Now I'm going to hit the radians that I know on those quadrantal angles. I know this is 0 pi. I know if I rotate 180, I'm at pi. I'm going to backtrack, so halfway would be pi over 2. To get this bottom one, I just have it memorized, 3 pi over 2. But if you need to count it, you're going to count by pi over 2. So this is 1 over 2, 2 over 2, check point. 3 over 2, 4 over 2, which reduces to 2 pi. Now I'm going to get my pi over 3, pi over 4, pi over 6. I just have it memorized that the 45-degree angle is pi over 4. I have that memorized because of the 45 and the 4. Okay? But if you don't have that memorized, you should notice that the 45 is 1/4 of the way to pi. Like that is sliced, that's one slice out of the 4 to get to pi. But I just have them memorized because of the 4's matching. I know for a fact this is pi over 4. now I'm going to hit every pi over 4 mark. And I'm just going to count the fraction. Don't forget, you always hit the quadrantal angles as well, every time. So this is 1 over 4. 2 over 4, checkpoint. Hope y'all are paying attention. 3 over 4. 4 over 4, checkpoint. 5 over 4. 6 over 4, checkpoint. When I say checkpoint, I mean something we've already written that would reduce and should confirm you're on the right track. This was 6 over 4. 7 over 4. 8 over 4, checkpoint. If you count the pi over 4 ones first, you won't accidentally mess up on the next one, because the next one is pi over 3, or pi over 6, sorry, and it's going to hit the remaining spaces left, all of the spaces left. So, this is a little bass backwards, so you got to be careful here. This is 30. You might think, oh, that's pi over 3. It's actually pi over 6, and that's because there's more slices of the 30. You see this? There's 6 slices there, and that's 1/6 of the way. So they're backwards. So the 30-degree angle is pi over 6. The 60-degree angle is pi over 3, because they're going 3. Think about it. 60 times 3 is 180, right? 30 times 6 is 180. So that's another way to remember which one's which. So I'm going to count. This is pi over 6. And now all of the empty spots will be counting 1 over 6. Ready? We got 1 over 6. 2 over 6 reduces to pi over 3. Hit your quadrantals. 3 over 6, checkpoint. 4 over 6 reduces to 2 pi over 3. 5 over 6. 6 over 6, checkpoint. 7 over 6. 8 over 6 reduces to 4 pi over 3. That was 8 over 6. 9 over 6, checkpoint. 10 over 6, 5 pi over 3. 11 over 6, 12 over 6, checkpoint.
So we can do them all as 1 of 3 and just simplify the fraction.
It won't hit the 45.
That's what I was thinking.
Great question.
It makes sense in my head, but I was
It won't hit the 45. But it would hit all but 45, and that would only leave 4. Coincidentally, 4. Pi over 4. Yeah. All that's left now is the the coordinate points. I like to do the quadrantal ones so I don't mess up 0, 1, negative 1. All right, so over here would be right 1, stay put. Up would be 0, 1. Left, negative 1, 0. Down, 0, negative 1. I would also recommend maybe putting the signs first before you start filling in the next part, because I have seen people remember all the hard stuff and then they forget the negatives. So it might not be a bad idea to say to yourself, okay, everything here is going to be positive. Here, x is negative. Down here, both are negative. And then to the right, y is negative. So it might not be a bad idea to fill that in by itself so you don't mess up that part. All right, last but not least, and this is where some people start to mess up, but it is pure memorization, and there's a trick to it, okay? let me retract that. It's not pure memorization. You could draw the triangle and get it. We did that the first day I showed it to you. I said, here's where these numbers are coming from. They're drawing a 30-degree triangle from here, and then you would have to have those numbers memorized. The short's 1, the hypotenuse is 2, the long's √3. The x-coordinate is cosine, so that's adjacent over hypotenuse. So √3 over 2 would be the x-coordinate. So if you forget the memory trick, draw a triangle and maybe the memory trick will come back to you. Here's the memory trick. Start up here. Start here. You're going to count. Ready? Watch how I do it. It goes by so fast. Just watch. You're going to count. 1, 2, 3, slide. 1, 2, 3. They all get a square root except 1, because the square root of 1 is 1. So square root, square root, square root, square root, and every single one of them is over 2. Every one of them.
That's not bad.
It's really not bad. I would encourage you to practice it so you don't mess up. The trick is you have to start up here at 60, and that you work your way down, slide over, work your way up, and then the 2. Once you get those 3, it is a reflection to the left or down, or like once you reflect to the left, that would reflect down. They're the same. So like all the 30-degree reference angles will be this point. It's just whether it's negative or positive. Okay? So don't mix it up. So what I like to do is I like to take that and go left, and I copy it. So this is 1/2 √3 over 2. We know that the 45 ones are always √2 over 2.
That's going to be a lot easier.
See, my negatives are already there, so I don't have to worry about it.
Don't stop. Just roll you out. No.
You can't mess that up.
Yeah, you can. I love ice cream. The chocolate drizzle. Oh, you can't be just.
Am I going to go to this game tomorrow just to watch you lose?
I'm just going to leave that open because the heat just off. All right. So now I'm going to take those points and I'm going to reflect them down here. The 30-degree reference angle is going to come down here. I don't know if I can.
Leave my feet up.
I can't get the whole thing to show in one picture.
Why did you have to scroll up? I thought you had it on memorized.
I have that memorized.
Oh, you just gotta remember it.
I have that one memorized.
So
I'm not gonna sit here and try and memorize those because then I'm gonna start confusing stuff.
It's just a pattern.
Yeah, it is a pattern.
So you just change the signs based on what project you're in?
Yes.
Yeah,
That seems
like
easy.
this one is that one is that one.
The only thing that's hard for me is like
You should notice that, let me get my highlighter. You should notice that like the 30-degree angle, right, matches all the 30-degree reference angles.
Yeah.
So that's like a way to check it. I haven't filled that one in yet though, but they should match. Because remember, it comes from drawing the triangles and doing the sine and cosine.
Yeah.
So it makes sense that since it would be the same triangle, just in a different quadrant, they should match but have different signs. This one down here, so I like to just come back up here to this one and reflect it down. So 30 would be this one, so this is going to be root. My negative disappeared. Oh no, this is x. Yeah, so this is not negative. There we go. And then this would be, so that's filling in the unit circle from memory.